morning. It is Tuesday, March 24th, and here's your warm-up for today. They ask us to graph the exponential function and identify the horizontal asymptote. So first, let's just review a little bit about what we talked about yesterday. Hopefully you gleaned that from your notes, even though my notes video yesterday was not ideal. So let's review a little bit. We are given an a value, our initial value. We're given an h, which is inside the exponent with the x. And we know that h corresponds to horizontal shift, and it's always the opposite of what we see here. So because h is a +1, that means we're shifting 1 unit to the left. And we have a k term at -3. K corresponds to vertical shift. So in this case, our graph is going to be shift 3 units to 3 units down. So if you remember from any of our other units where we studied graphs of functions, the a corresponds to how fat or how skinny or something is. That's true here as well. And if this were negative, predictably, just like it does for any other function, it would be flipped across the x-axis. In this case, it's positive, so it's not flipped, but just pointing that out to you. Okay, let's go ahead and fill in our table and graph our function. First of all, when you punch this into your calculator, make sure that you recognize that the x + 1 is together inside the exponent. So we would plug this in, 2 times 1/2 raised to the parentheses -2 + 1 power, so that -2 and +1 are located inside the parentheses together. And then the -3 is outside the parentheses, saying we're subtracting 3 from the entire function. And I have these filled out already to save some time here. Okay, and just looking at the table, we can already predict what the horizontal asymptote is going to be. We see that as the x values increase, the y values get closer and closer and closer to -3. So if you've noticed this from yesterday, hopefully you saw this pattern. The horizontal asymptote is always the k term. And it makes sense. The horizontal asymptote of the parent function, the original dk function, is the x-axis, y = 0. And in this case, if our entire graph is shifted 3 units down the y-axis, then it makes sense that our horizontal asymptote is shifted down 3 units as well. So I'm going to go ahead and sketch this graph here. Okay, and if this dotted line represents y = -3, then we can see that our graph gets closer and closer to that dotted line, but never actually crosses it, never actually meets it. So in this case, we have a horizontal asymptote at y = -3. So once again, your horizontal asymptote is always your k term.